The cube power doesn't work here because it's not cubed though.
Well, I like apply the same principles, like kind of like how you do Pascal's triangle.
Huh.
I have like 50. What number is it?
I don't know, 78. All right, so here's your group leader. Here's your group leader. Where you been?
I forgot today's Wednesday. I'm so sorry.
You forgot today's Wednesday. All right, so now I honestly don't know how to do the difference of cube, but it's possible, I guess. Wait, I'm trying to think. Is it possible? Or not like I know of, but okay. Well, anyway, I'm gonna show you that you can do long division or standard division. So the work is over there. So yeah, so you can actually start with a 1. And this is the 5th degree, 4th degrees, 3rd degree, 2nd degrees, and the 1st degrees, and 32. Wait, how many 0 are there?
4.
4 is x to the 4th minus 32. Okay, anyway, this is drop 1, this is 2, and this is 1, this is 2. Is that okay?
Isn't it only asking 3 0?
Yeah, I'm confused. 1? How many 0 are they? Okay, 4 0. Sorry, let me erase this. So this is a 2. This is a 2. And this 2, that's going to be 4. And this is a 4. Is that okay? 8. And this is what? 8. And this is, wait, hold on a second. 1, 1. 1, 2, 2, 2, 4, 4, 2, 8, 8, 2, 16. And this is a 48. Is that right? So then you should get limits as x approach 2 of x. Did I do something wrong? Hold on, let me do long division. Just speak safe. Plus 0 x to the 4th plus 0 x to the 3rd plus 0 x squared plus 0 x. It's a 4 zeros.
By the way, do you recommend Khan Academy as a resource for studying this?
Minus 32. And that's x minus 2. So that's going to be x to the 4th. That's going to give you x 5th minus 2x4. This is a minus sign, so that's going to be 2x4 plus 0x to the 3rd. This is a plus 2x to the 3rd. This is a 2x to the 4th. Minus 4x to the 3rd. Minus sign. This one is going to be 4x to the 3rd plus 0x squared. So that's going to be plus 4x squared. So it's 4x to the 3rd minus 8x to the 2nd. That's going to give you 8x second plus 0x plus, what is it? 8x. So it'll be 8x squared minus 16x. And this is 16x minus 32 plus 16. And that's equal to 16x minus 32. And that's equal to 16 negative 32. That's 0. So that's this. Sorry, I did it wrong. So it'll be x to the 4th. So it's x minus 2. X minus 2 times x to the 4th plus 2x to the 3rd plus 4x squared plus 8x plus 16 over x minus 2. And let's cross it out. So that's going to be 16 plus 16 plus 16 plus 16 plus 16. That's equal to 80. Why did I do synthetic division wrong though? Hold on a second, let me double check. 2, 1, 2, 2, 2, 4, 4, 2. This is negative 32. So, yeah, this is not a 0. My fault. So this is 0. This is a 16. And that's 16. That's 32. That's 0. Yeah. So, so this is the question that maybe everybody has. Any other questions? Yes.
61.
What does 61 says?
It's really long. It's x plus delta x.
Is delta x approach 0, right?
Is
Okay. X plus delta x
squared
square
minus 2 parentheses x plus delta x plus 1. So then negative x squared minus 2x plus 1.
It's a parenthesis, right? Okay. So this question is actually, we're going to talk about this particular question later, but this question is interesting. If I were to plug in delta x equal to 0, I'm going to get 0 over 0. The first thing is to plug in 0. So just think about delta x as a variable. If you plug in, that's going to be 0 over 0. So if that's the case, that what you're going to do is you're going to expand that. You're just going to do math because there's not much math you can do. And this is going to be x squared plus 2 delta x plus delta x squared. Is that okay? Is that okay? Minus 2x minus 2 delta x plus 1 minus x squared plus 2x minus 1 all over delta x. I just distribute everything. Now, hopefully I can simplify something. So let's try to see this x squared, this is x squared. This is 1 and this is 1. That's minus 2x, this is plus 2x. Is that okay? And then you have this thing left. Limit as delta x approach 0 of 2 delta x plus delta x to the square minus 2 delta x. What happened?
Cancel out the 2 delta x.
Yep, you are absolutely right. I didn't see that. Okay, so this one is going to be delta x times delta x, right? Over delta x, right? Hold on, I'm missing something. Wait a second. Delta x squared minus 2x minus 2 delta x plus 1 minus x squared plus 2x minus 1. I'm missing something. Hold on a second. Yeah, but I don't want to cancel out everything. That's not correct. Something is wrong. Hold on a second.
Should just end up with delta. Yeah.
No, it should not be. It should be end up with 2x minus 2.
Because you didn't do a 2x delta x value.
2x delta x where?
Like, it's like, I got the same answer, but I did a 2x delta x value. No, because like when you
Hold on, let me check. Delta x, 2 delta x.
when you bring
Delta x squared.
when you do x plus delta x times x plus delta x.
Yeah, so that's x squared. No. Oh, this is x delta x. You're right. Blindly. Okay, so this cannot cancel. Right, so hold on a second. Let me redo it again. Let me do it again. So this one is going to be x squared plus 2x delta x, I missed that, plus delta x squared, minus 2x minus 2 delta x plus 1 minus x squared plus 2x minus 1 over delta x. So the x squared cancel out with the x squared. The 2x cancel with the 2x. And the 1 cancel out the 1. And then you have to factor out a delta x here. And that's going to be 2x minus 2 over delta x. And the answer should be 2x minus 2. Yeah, you just have to distribute it properly. Sorry. Thank you. Missing an x. End up pause big. So delta x is just a variable. You can put it as h if you wanted to, so it makes it easier. Okay. Can I go to today's stuff? Okay. Carlos, can you help me bring that water bottle back in front? Thank you. Okay. I need to use that. Oh, I have a water bottle, but I need to use that water bottle. Thank you. So today we want to talk about a couple of things that's super important. So today, even through a short day, we're going to talk about very important stuff. We're going to talk about only theorems. The problem of theorem question are usually the hardest questions. But if you understand theorems, the question's so easy. But you have to understand them. So I'm going to explain a way that you can understand. Hopefully you can understand. So we're going to talk about 3 different things. One is the definition of continuous. Okay, so definition of continuous. No, I will not suggest Khan Academy. I suggest you do homework. And I suggest you do homework before you leave this. So, so the thing is about Khan Academy doesn't help you here because Khan Academy is not helping my test. Because my test is, I'm the one of the kind test. You're not going to find other tests like mine. So you're going to have to figure out a way to be able to do well in this class. You have to figure out how to take notes and how to do well in the test. That means put your computer away right now if you cannot read the computer while you're taking the notes. So Stefano, put your computer away. So the first condition of being continuous, the first thing about being continuous is FA must be defined. This is one of the most common tested on AP exam, theorems, the definitions. The FA must be defined. So that means I will have something like this. I will have A, and this must be defined. So it's a black dot. It's a black dot. Second condition says limits as x approach to A of f of x must exist. So must exist. Now, what does that mean? That means this. That means limit as x approach to A from the right of f of x must equal to limit x approach to A from the right of f of x. But that doesn't mean it's continuous because if I limit x approach to A like this, is this function continuous? Is it continuous? No, it has a hole, right? Think about you have a roller coaster, right? you cannot go through that hole, you're gonna fall off. Unless your fit is inferred, then that's different. Okay. So the third thing says, well, the third condition is actually interesting. The third condition is a must because the third condition says, well, how do I make them continuous? I can do this, right? And I can drag it down like this. You mentioned that's not continuous right now. And this is continuous right now, right? Does that make sense? So how do I write that in terms of mathematical way to write it? Well, I can write it like this. As limits as x approach to a from the f of x is equal to f of a. Because the first condition and second condition equal to each other. Equal to each other, this look like this. And therefore, that's continuous. On the test, I'm going to tell you, this is directly on the test. I'm going to write down says, what is the definition of continuous? If you write down those three conditions, you get a point. That's the easiest point. Make an index card, know it. It's on AP exam multiple times in the multiple choice. And there's a definition of continuous, there's a definition of differentiable. But they all are built on top of each other. First, by understanding continuous. And that's the first idea. Is that okay? And this is definition of continuous. After that, another most popular thing tested, all the things that we write down right now, is it better to study the notes than anything else because the notes is going to help you. This is the part that you have to study. And I already told you before, no study in math, but this is the part, unfortunate definitions and theorems that you have to look over and understand them. So it's the best time to look over and is during lunch. Make sure you understand everything. Now, the next thing is the intermediate value theorem. Now, I did this in high school. When I was in high school, they taught intermediate value theorem in algebra 2. I was so confused. I have no idea what to talk about. I started understanding when I'm taking calculus, understand a lot more. But the intermediate value theorem is tested in algebra 2 when I grew up. It was tested in pre-calc. It's tested in calc. But normally people don't understand until calculus anyway, because nobody can explain it very well. So in order for intermediate value theorem to work, it must have some type of condition. So there was 3 conditions. First condition says f of x must be continuous between a to b. Between a and b. It has to be continuous. Second, f of a does not equal to f of b. Again, this is probably the index card you want to review before the test things. So I'll make an index card. Third thing. There is a k value, and you're gonna say, what is k value? Must be between f of a and f of b. The result of the theorem, the last result is there at least one c value where f of c is equal to k. F of c is equal to k. And that's it. You're gonna be like, what the hell is this saying? It's so complex. But I'm gonna break down slowly for you. So let's just say if I have a graph, and this graph is A and this graph is B. And there was some type of output. We're gonna say this is f of A and this f of B, right? And this example is like this. And not just say if I have a if I have an easiest continuous function. What is easiest continuous function? Straight line, good. Alex is a genius. So it's a straight line, right? And we also say that there is a k right here. K is between A and B. So you're gonna say, okay, well, yeah, there was a value at C value. There was a C that equal to K. And you're gonna be like, this is very intuitive. It's not like it's common sense. It has to go through K. It makes sense. But why do they say at least one value? At least one C value? Why? They are infinite value 2 points, but there was only one K value here. Yes.
Is it if it's like the function's not a straight line?
Good. What if we have a function that is not a straight line? So let's just say if you have A and B and f of A and f of B, and there's a K here. And I can go like this. From this point to this point, I can go like this. Right? So ideally, there was a K here. There's C1 value. There is a C2 value. There's a C3 value. Right? There's more than one C value. So they say at least one C. If it's a straight line, there's one C. Now, here's what they're going to ask me. It says, well, what if the condition is not met? If the condition is not met, it does not have to go through. If you think about it, right? So this is an example, it doesn't work. This is not working. So IVT is not working. So not working IVT. Why? Because you have a and there's a B and there's f of A and there's an f of B. And then I go from here to here and there's a K. And I can have this function like this, and I can have this function like this. Well, the problem with this function is not what? It's not continuous, right? If it's not continuous, do I have a value where K is equal to C? Or f of C is equal to K? No, because I don't have this value. If you look at back here, there's no value. So they have to be continuous in order to work. Now, why is second condition is important? Because second condition is going to give you exact same height if FA is equal to FB. There is no K value in between. So it has to have the K value in between. If you don't, it doesn't work. Okay? Now, I'm going to give you an analogy that's kind of makes sense. For example, I have label here. I have label FA, I have label FK, I have label FB here. Imagine me, like, I always have problem drinking water. Like that's my biggest problem. I'm so unhealthy because I don't drink water. You see me water line up here. I have one bottle and one bottle. I don't drink water because I will bring water, but I'll forget to drink it because every day I'll start lecturing and I'll forget everything. And so that's bad. So every time you see me say, Mr. Make sure you drink water. So imagine that, what does this prove? This proof that says f of A is right here, f of B is right here, the K is right in the label. So this proof says if in the first period you come here, you take a picture, it's right here. And the water is completely full. And after school tutoring, you take a picture right here, it's all the way down here. So it does not tell you when does Mr. Ye drink past this label. It just tells you Mr. Ye has to go through this, he to drink his water, but doesn't know which period it is. It does not define the time when it happened. It should tell you it happened throughout the times. Why? Because water is what? What's the first condition? Water is continuous. Because there's no way that I can drink the top part of water and drink bottom of part of water and not drink in the middle part. Because water is continuous. Does that make sense? So if you take a picture in the morning, it's right here. If you take a picture in the afternoon, then they must have to go through. It does not tell you when. It may be a lunch, maybe a third period, maybe a second period, maybe a first period. Can I drink more than once? Yes, I can drink down, I fill back up, and I drink again, I fill back up. So you reach C at least once. At a minimum once. If you take a picture, it's right here, take a picture, it's right here. He must pass through this once. This is a simple theorem. It's not hard. But this on the AP exam last year, a lot of people mess up. This year, you got to make sure you understand them. What would a question look like? The question will look like something like this. I would say f of x equal to 3x squared minus 4. And between 0 to 2, prove that there is a 0 between 0 to 2. Prove that there's a 0 between 2. And how are you going to prove it? You're going to start listing down the condition. Understand the condition. The first condition is what? Well, it's f of x is continuous. You're going to say f of x is continuous because 0 to 2, because it's a parabola. It's a parabola, it has to be continuous. There is no gapping, there's no nothing. Right? Any polynomial is continuous. So you can say because it's a polynomial. Anytime you have polynomial, it's continuous. We're going to talk about when it's not continuous. Second condition. If f of 0, well, f of 0 is equal to what? If I plug in 0, what am I going to get? Negative 4. And the f of 2 is equal to what? F of 2 is equal to what? 8, right? So guess what? We fulfill the second condition because they're not equal to each other. And third condition is 0. So there was a 0. 0 means y equal to 0. Right? So you said negative 4 less than 0 less than 8. The third condition fulfilled because there was a 0. Can it be a 1? Yeah. 1 is between 8 and negative 4. Okay? And you can say, okay, well, IVT prove that there is a 0 between 0 and 2 for f of x. We don't know when, but I know when. If you set it equal to 0, you solve it, it's going to be like 2 over square root 3. X equal to 2 over root 3. But I don't care about when. I care about it just if he drinks the water. It does not tell me when. You don't need to care about when. As long as he after school tutoring, Mr. You must drink water all the way here. If he doesn't, make sure you drink it. Okay? Does that make sense? Now you're going to say, when does IVT fail? Right? For example, what if your f of x equal to 1 over x minus 1? Yeah? IVT, intermediate value theorem. I just stand, on AP exam, you can write down IVT. It's called intermediate value theorem. Proof that is 0. There is a 0. So proof that there is a 0 between this. And let's say negative 1 to, let's say, 4. Is any 0 between those two values? William says yes. Alex says yes. Anybody else says different?
All that. I don't know.
You do realize I don't mind Alex using his phone just because I do know like Alex does use decimals pretty often. Besides playing Heyday. So in this one, f of x not continuous. Do you know why it's not continuous?
It's two different. It's not one continuous line.
Yeah, if you graph it, it's gonna be two different, but why is not continuous? Because the asymptote. Because asymptote at where? X equal to 1. It's not continuous. But doesn't mean there's no zero. Actually, there's no zero. If you really graph it, right? If you really graph on decimals, it's gonna says 1 over x minus 1. There is no zeros because it's not continuous. Even though there's a negative value here and there's a positive value here.
So isn't always going to be no zeros in its like that? So it's only if it's asymptote.
It was in denominator equal to 0 in interval. That's what it's not continuous.
Okay.